On number 5, it says, an ecologist is conducting a research project on breeding pheasants in captivity. She must first construct suitable pens. She wants a rectangular area with two additional fences across the width. Find the max area she can enclose with 3,600 meters of fencing. So if you draw the picture here, I'm going to call each of these X and then the ones across Y. You could label the X's as the Y's and the Y's as the X's, so opposite of what I'm doing, and your math might look a little bit different, but in the end you'll get the same answers. So it doesn't really matter what one you call X and which one you call Y. Okay, so we need to look at what we're trying to optimize, and we're trying to maximize the area. So that's very important that is our goal. So the area is equal to X times Y. And just like with the previous problem, this is too many variables. So we need to use more information about the function in order to get our area function only in terms of X. So that information comes from the fencing. So I know that I have 4 X's plus 2 Y's, and I know that we can only use 3,600 meters of fencing. So if I add these up, this has to be equal to 3,600. So I want to solve for Y here. So if you subtract 4X from both sides, then 2Y is going to be equal to negative 4X plus 3,600. And then I want to divide everything by 2, so Y is equal to negative 2X plus 1,800. So this is the extra information that I need to use in order to get my equation that I'm trying to maximize only have X's and not X's and Y's. So A is going to be equal to X. Instead of saying times Y, I'm going to say times negative 2X plus 1,800. So then if you distribute that, then A is equal to negative 2X squared plus 1,800X. And this is what we're going to call the original equation. Meaning this is our equation before we do anything with the derivative or anything with critical numbers. This is our starting off spot. So we do need to take the derivative. So A prime is going to be negative 4X plus 1,800. And then I want to set this equal to 0 for the critical numbers. So this one shouldn't be too tough. If we just subtract, or actually I'm going to add 4X to both sides. So 4X is going to be 1,800. So X is going to be 450. Now again, before we use this for our answer, we do need to prove that it actually is a maximum. So if you put this on the number line and set y1 equal to the derivative and put in some test points, then you should get a positive number here and a negative number here, which means that we have proven that this is a max. So the max is at 450 for the x, and the area is going to be, if you plug x into the original equation, it's going to be 405,000. So the question is specifically asking for the max area that she can enclose. So that will be the 405,000. And this is square meters. The dimensions, they don't ask for it, so you don't have to put. So if they asked, this would be 450 meters by, and then you can figure out using the y equation. So again, I plugged the 450 into A in order to get A. I'm plugging the 450 into the y equation to get y, even though they don't ask me to. So this would be 900 meters. And that'll be our answer.